apply the section 4B, the off payments, too. So we use a given interest earning period to evaluate present value. So if the payment is monthly and the interest is given annual, then we use a year for the time unit. So example 1. The annual effective rate is 3% and $1 is paid at the end of every 5 years for the 6 times. What is PV? So this is the same question as the last time, but this time we use 1 year as time unit because the interest rate is given annual. So time unit, 1 year. And we use a new idea to calculate this present value. Time diagram that start with 0 and end with 30, and the payment happens only multiple of 5. But we think about the equivalent annual payments. So I would say that the payment of R, which have the same present value as this $1. And the subsequent payments, we do the same thing. We only have $1 every 5 years, but we think about the payment of $R every year, which corresponds to this $1. And we continue up to 30. So we have 25 and 30. So we consider the 30 payments of R, so that is regular annuity immediate, which has equivalent present value as this 6 payments of $1. Then after that, we calculate the present value. The present value of the cash flow above this time diagram is usual annuity immediate. So we can use the annuity immediate formula to get this. So we have 2 steps. At first, to determine R. Then second step, we calculate present value. So step 1, so determine R such that the 30 annual payments of R have the same present value as this, the 6 payments of $1. So 5 payments of R corresponds to this 1 payment of $1. How to calculate this? This can be done with the formula of future value of the annuity immediate, accumulated value of annuity immediate. So by definition of S right angle N, we can say that the accumulated value at time 5 of the first 5 payments of R is equal to R times S right angle 5 at 3%. Then this is equal to $1. So this R times S right angle 5 at 3% is equal to 1. So that means R is given by the 1 over S right angle 5 at 3%. And we can calculate this S right angle 5 at 3% by BA2 plus. But we leave it for now, then we continue to calculate present value. What is the present value of this annuity? I mean the double asterisk, the 6 payments of $1 every 5 years. Present value of this cash flow is the present value of 30 payments of R. And this is by definition of annuity immediate, R times A right angle 30 at 3%. And R was 1 over S right angle 5. So this becomes A right angle 30 over S right angle 5. And each quantity can be calculated by BA2 plus. The denominator, we can use the 30 as N and the 3 as I over Y, and the payment as $1 or negative $1 if we want to get the positive present value. And S right angle 5, you can say N is 5 and 3 is the interest rate, and the payment is 1. And the future value you can calculate. Then this will become 19.600 divided by the 5.3091. So you get this as $3.69. So this is the same answer as the previous section. So we solved this question in another way. So how about the general case? So in general, if we have a time diagram from 0 to n times m, but payment is every m years, so in total, we have n payments of $1 and annual effective rate is I, then present value is A right angle NM at I over S right angle MI. So this is a generalization of step 2 in the example. So this is the formula for general case. Yeah, we have another way to solve this example 1. So basically, this is more plain way to solve the question without using any formula. We have 30 years of payments, and we can calculate present value for each payment. Then after that, we can take summation. So always we can use that method to solve the question. So 20, 25, 30. And we can think about the present value of each payment. For example, $1 at time 5 is worth the v to the 5th power at time 0. $1 at time 10 is worth v to the 10th power at time 0, and so on. So the present value of this annuity at I is equal to 3%. And here V is equal to 1 over 1 plus I, so 1 over 1 plus 1 over 1.03. Then present value is V to the 5th power, V to the 10th power, V to the 15th power, up to V to the 30th power. So if we summarize this, it becomes this. And we can use the summation formula for geometric sequence. Then that is the V to the 5th power minus 1 minus V to the 30th power minus 1 minus V to the 5th power. So if you plug in v is equal to 1 over 1.03, the v to the fifth power becomes 0.8626, and the v to the 30th power, that is negative, sorry, the 0.4120. So in total, this becomes 3.69. So again, we got the same answer. So we have many ways to solve this kind of question. So the different strategies that needs different formulas, and this method, for example, that doesn't require any formula, but that needs some more algebra.